killed a snake yesterday. This is about it.
Did it?
Yeah.
Did it bring it into your house?
No, it was a garden snake. I left it by the car.
Little one?
It's kind of big.
That would still freak me out. Okay, so yesterday, did we fill out the table portion? Did we get that far? Okay. And were we starting to analyze the two limit parts?
Yep.
Or did we already fill those out?
There's two, right?
That was on 14, page 14.
The wrong one.
I think we're on 15. So this was like negative 18, negative 48, negative 498, negative 4998, 5002, 502, 52, 8.67. Okay, so let's take a look at these two limits. We were introducing limit notation yesterday, like how it's written mathematically. This first one's telling us if we were to get the x values closer and closer and closer to 3, what's that little guy telling us? Little minus sign? From the left. So if we were to get really close to 3 from the left-hand side, looking at the x values, what would this function, aka y values, be getting closer to? So when you look at your table, we can hopefully see that 3 is somewhere in there. But we don't know exactly what's happening at 3. What we're concerned with is this limit. What's happening as we get closer to 3. Okay, we don't really care what's happening at 3. We're looking at what's happening as we get closer. Go, Dan?
Negative infinity.
Right, so as you get closer and closer and closer to 3, from the left-hand side, notice how the y values are getting more and more and more negative. So the y value, aka the height of your graph, is very, very negative. It's like you're dipping really far down. The other limit, as we approach 3 from the right-hand side, what are the y values from the graph doing? Go, Dan?
Approaching infinity.
Positive infinity. Yep, notice how they're getting higher and higher and higher, more positive. Okay, so this one's a little different than the one we did on page 14, because on 14 you saw how we were actually approaching a number. Realize how the numbers were getting closer to 2. Okay, but in this case we're not approaching a number, we're getting either more and more positive or more and more negative. So you might not always have a number here, you might have that infinity idea. Now we can see this graphically because you have that picture at the bottom. So remember, this is the same example we did yesterday, the same equation. So here's that value of 3, and if we were to trace the graph on the left-hand side, notice how it's getting more and more negative. It's going down forever. If we were to trace the graph on the right-hand side, it's getting more and more positive. It's going up forever. So the information from the table is confirmed by the graph, the picture. It's all connected. Okay, it's all making sense. So maybe we can write this idea. As x approaches 3 from the left-hand side, the graph of f of x, how do you want to describe it? What wording might you want to use? In your own words, no right answer really. How would you describe it? As we approach 3 from the left, how can you describe the graph? Good, Braden?
Approaches negative infinity.
Approaches negative infinity. You could say continues downward forever. Okay, same idea, different wording. Okay, and similarly on the right-hand side, as x approaches 3 from the right, the graph of f of x, we could say approaches positive infinity, or you can say continues upward forever. Okay, similar idea. We didn't lose it from yesterday? At least not yet, right? Okay, so what we're going to get into today is kind of the definition of a limit, and bringing it back to like the little Mean Girls clip I showed you, we're going to see when does a limit not exist. Okay, remember a limit is the y value your graph is approaching, okay, the height of your graph. So there's a stipulation in order for a limit to exist. Okay, this is called the limit existence theorem. We're going to say, okay, so we're going to write it down, but we're going to go through some examples just so that it makes sense. The limit as x approaches a, remember a is normally a number, the limit of a function exists only if, okay, this has to happen. If this doesn't happen, we say the limit doesn't exist. Okay, the limit exists only if the limit from the left-hand side of A is equal to, meaning the same, okay, is equal to the limit from the right-hand side of A. So if you were to picture in your head, okay, tracing a graph, as you come in from the left and as you come in from the right, they are approaching the same point. Okay, they have to be equal. You are approaching the same value. And not only do these have to be equal, but we say they equal some number, we'll call it b, and this b value is a real number. We'll see an example where b is not a real number, so that kind of gets a little confusing. Okay, so graphically speaking, if you were to trace your graph from the left and you were to trace your graph from the right, if they look like they're going to be matching up, the limit exists. Okay? If they don't, we say does not exist. They have to be matching up. Okay? So let's take a look at our first graph here. Find each of the following from the graph. If you were to approach 2 from the left, how would you describe the height of the graph? So find that x value of 2, trace the left-hand side. As you get closer to 2, what's happening to the height? How would you describe it? Good, Dan?
It's getting close to infinity.
It's getting close to infinity. It's going up forever. Good. Let's check out B. As we approach 2 from the right, so again, that same location of 2, this time we're going to trace the right-hand side. How would you describe the height of the graph? Looks like this one's going up forever too, right? So this would be infinity. Okay. Let's take a look at C. F of 2. What's that notation telling you to do? Plug it in. So if you were to physically plug in the number 2 into your graph, what y value or height would you get out? So if you tried to plug in 2, what would you get based off that graph? What point value? Undefined, because you have an asymptote. Perfect. Okay. So notice how the limit is a little bit different than a point. A point is if you plug in that number, what number do you get out? Whereas a limit is what are you approaching? What are you getting closer to? So, last one. Does the limit as x approach 2 exist or not? And then explain why. So, the limit existence theorem, in order for a limit to exist, the left side and the right side of that number have to be equal. Didn't we say that they are here? Right? The left of 2 and the right of 2, didn't we get the same thing? Okay? But they have to equal a real number. Is infinity a real number? No, it's not even a number, right? It's an idea. Yes. Hey.
I just dropped something off too.
Yeah.
Sorry guys.
It's okay.
This is just the concept. Perfect. I'll probably pass it out. Is there anything I should know? Here's the website you go to. It's just GRIF.ly/. Oh, I'm sorry. It's probably about this. It's okay. So they go to this website to register.
Okay.
And the register basically.
They also have and there's nothing that I need to turn into review. They just online.
Yeah, and there's there's drop down. It's like for othering regarding to the sentence.
Okay. I'll probably write on the board.
Any questions, just enough to see these.
Okay. Thanks. All right. Is infinity a real number? We already said no, right? Infinity is not even a number. So we have to be careful. Yes, the left and right side are the same, but they are not equal to a real number. So does the limit exist? We say no, definitely no. Why? Because what? What do you feel like saying? Good, right?
B is not a real number.
B is not a real number because infinity is not a real number. Okay. So there's kind of, I guess, two stipulations going on here. The left and the right side have to be the same, and that number has to be a real number. Two things going on. All right, let's check out the next one. Find each of the following from the graph. Very similar example. As we approach 2 from the left, what is the height of the graph? So here's that x value of 2. If we were to trace the graph on the right-hand side, getting closer and closer to that 2 value, what is your height getting closer to? What y value are you getting closer to? Good, Brayden? 2. Notice how you're getting closer and closer to that hole, and that hole has a height of 2. Now if we were to trace the right-handed side of 2, getting closer and closer, looks like we are approaching 2 again, right? What if we were to plug into, okay, part C, if we actually plugged into, what height would we get out? -3, right. So there's a little difference there. All right, does the limit exist? Good, Dan?
No,
Why not?
because as we see, the limit only exists if the limit of x to a from the left and x to a from the right equals b, which b is that value, which b is -3 in this case, which 2 is not.
Okay, b is not -3. B is the number that both of these limits equal.
Oh.
Okay, now, this existence theorem has nothing to do with f of a number. We don't really care what the point is. We care about what we're approaching. So that's what's a little tricky. Okay, so when you're just looking at the limits, notice how the left-hand side we approach 2, the right-hand side we approach 2. We don't care what's going on at 2. Okay, I don't care that that's -3. I don't care if it's positive 100. All I'm concerned about is how you come in from both sides. Are they approaching the same thing? So the left side and the right side are the same number, and is that number a real number? Yes, 2 is definitely a real number. So we'll say yes. Why or why not? Perhaps maybe because the left and right limits are both the same real number. All right. The whole idea of a limit is what are you approaching. We don't care what's happening at that point. We care about what are you approaching at that point. Okay, next one. Find each of the following based off the graph. This whole thing is dealing around 2. As we approach 2 from the left, what height are you getting closer and closer to? 3. As you approach 2 from the right, what are you getting closer and closer to? A -3. So maybe you guys can automatically answer part D, right? But before we get there, let's try C. If you were to plug in 2, what height would you have? 3, right? That closed circle. Good. All right. So does the limit exist? If you were to trace from the left and the right, would they be matching up? No. Bless you. So no, because the left limit does not match or equal the right limit. Okay, again, we don't care what's happening at the point. I don't care if it's 3, I don't care if it's -3, I don't care if it's undefined. A limit is all about what are you approaching. Is it starting to sink in? Okay. All right. Yes, go ahead. Okay, so based on what we've seen so far, does f of a have to be defined in order for a limit to exist? Does the point actually have to be there in order for you to approach something? Brady, why are you shaking your head? That's good.
Because there was a hole in the last one and it existed.
Exactly. If you look on the last page, okay, notice how the limit existed, right? We said yes, but that point was not defined there. It's defined somewhere else. Okay, so the point value does not necessarily have to exist. Yeah.
But doesn't the point value still exist? It's just in a different location.
Sure. Well, what if I said this point wasn't even there? Then this would be undefined, right? That still doesn't change our limit,
Right.
our limit values, right?
Yes.
It's just that it's defined somewhere else. Okay, so we're going to draw 2 examples. Draw an example, 2 different graphs to justify your reasoning. Let's say we had a hole, like in the last example. And maybe we'll have a jump in this one. So if we take a look at the first graph, notice how if I were to approach A from the left and A from the right, wouldn't my fingers eventually touch each other? They're approaching the same spot. Okay? So the limit as x approaches A of this graph exists. As you come in from the left and the right, they're going to match up. But notice how the point value doesn't exist. If I tried to plug in A, like I tried to plug in 2 into the other examples, if I tried to plug in A, this does not exist. We can use DNE as an abbreviation for does not exist. So again, the point value means nothing. A limit is just what are you approaching. What about the second graph? Does the limit exist at A? If you were to trace the left side of A and the right side of A, would your fingers be matching up? No. So in this case, the limit as we approach A of the graph does not exist. If I tried to plug in A, would I have a point somewhere? Is there a closed dot at A? No, right? They're open as well. So here's what we got to be careful about. In both cases, notice how the point doesn't exist, but depending on what your graph looks like, the limit might exist, or it might not. Okay? Whole idea of a limit, as you come in from the left and the right, you're meeting up at the same point. Okay? Let's try another table of value example. This time they give us the table. We don't have to figure it out on our calculator. So we're going to use the table to answer the following questions. If we were to go very, very far to the left, okay, our x's approach negative infinity, what does the height, aka y value of the graph, seem to be approaching? Looks like infinity, right? So in a table of value, negative infinity is traveling all the way to the left. So if you were to start to look at the trend of your y values as you travel to the left, notice how they get very, very large. So it looks like we're going towards negative infinity. Okay. They also gave us maybe a tidbit of information here. This is an exponential function. Okay, so it's a very quickly growing graph. let's check out this one. As we approach -3, what does the height of the graph do? Okay, so remember, we got to come in from the left and the right and see if we approach the same thing. If we approach -3 from the left, and if we approach -3 from the right, what does the height look like it's getting closer to? What are we kind of narrowing in on as our height value? We're narrowing in on 9, yep. As you come in from the left and the right, notice how you're getting closer to 9. All right, let's check out 1. As you approach 1 from the left and the right, what is your y value getting closer to? Can you tell based off the table? Good, Ariana? 1.5. Good. And the last one, what if we were to trace the graph all the way to the right, towards positive infinity? What do your y values look like they're doing? What are they getting closer to? 1. Good. Okay. Are we doing okay? Yeah? All right, let's check out the next one. Below is a table of value of the rational function. That's one of our asymptote looking type graphs. So we're going to try this one. Do you guys want to try it on your own? See how you do? Maybe? Give it a shot. I'll give you a few minutes, okay? Make sure you pay close attention to if you have any pluses or minuses in the exponent spot. Okay, that just means from the left or from the right. You're only going in one direction. Let's see, any takers? Any of the 6? You want to try one? Good, Dan. Which one do you want to try?
The D.
D, all right. As you approach 2 from the left and the right, what do the y values look like they're getting closer to?
0.3335.
0.3335, something like that? Okay. I would say that's roughly 1/3, somewhere, something like that, okay? How do we do? Notice how as we approach 2 from the left and 2 from the right, the point is undefined, right? We either have a hole or an asymptote there. Okay, the point is undefined, but we're trying to figure out what are we getting closer to. Notice how the left-hand side and the right-hand side are extremely close together, but the actual point doesn't exist. Can we describe what's happening graphically? Can we narrow it down? Like, is it a hole or is it an asymptote based on that table? Good, Ariana? It's a hole, right. Notice how the left-hand side and the right-hand side are very close together, but at that point of 2, it's undefined. Okay, it's an open circle. So the limit exists when you're talking about a hole, because notice how the left and the right do meet up, but they don't actually touch each other in that case, because we have a hole, it's undefined. Okay, so it's a little tricky because the table we had before, for instance, as we came into -3, we approached 9. Okay, that's an actual number. I bet some of you wrote undefined for that one, right? You got to be careful. Okay, you got to think about, notice how the left and the right are really close together. Okay, so that is a limit. They're very, very close. What about any other ones? Any of the 5 that are left? Good, Braden? A is 1. As you trace the left-hand side of the table, forever towards -infinity, it looks like we're approaching 1. I like that. What about a 4? Go ahead. E is 1 as well as we go forever to the right. Yep, we're leveling off at 1.
B is infinity.
B is infinity. As we approach -1 just from the left. What'd you say it was? Infinity, yep. Notice how we go from 1 to 2001. We're growing very quickly. We're going upwards. Okay? Well, some of the other 2. I'm going to give you a breakdown for a second. What about my ladies in the back? Anastasia or Alexis? You want to tackle one of them? I'll come back to you in a second. Vinny, you want to give me one? F, B does not exist. Alright, so when you take a look at F, as you approach -1 from the left and the right, are they meeting up? Okay, we said the left-hand side is going up forever. The right-hand side looks like it's going down forever. Those are not meeting up, right? We have this motion, kind of like an asymptote going on. Okay, so that would be it does not exist. C would be -infinity. Yep. As you approach -1 from the right-hand side, notice how your numbers are getting very, very negative. You're going down forever. So we said there was a hole at 2 and an asymptote at -1. That might be useful to know for maybe some other question. Okay? Did we get some of them? They can get kind of tricky when you start talking about rationals because you have those holes and asymptotes and things going on. Okay? That's our first spell, guys. Okay? How about you guys try a few more? Do you want to try a graphing one? You want to do a few together? Or you want to tackle them on your own? Can you try some? Give it a shot. Just as a reminder, if you don't see that little plus or minus in the exponent spot, you have to come in from both sides. You have to check the left and the right. Yeah.
When did you say the summer after this year?
September 4th. Yep, day after Labor Day. Be careful so it doesn't break and then you don't go all over. All right, we'll check out a few of these. We still have another one of these to go over together, so maybe I'll let you do that one by yourself too, but I want to make sure we're all on the same page. If we take a look at A, we're going to approach -3 just from the left. So here's your -3 location. If you were to trace the graph on that left-hand side, how would you describe the height? What are you approaching? Good, CB? Positive infinity. Good. All right. Part B, we want to approach -5. There's no plus or minus, so that means we have to come in from the left, or from both sides. So -5 is somewhere right here. We got to trace the left side of that -5 and the right side. Are they getting close to the same point, or are they not? They are getting close to the same point, so that means the limit exists, okay? And what is that point that they're getting closer to? What's that real number? What's that height? Go ahead, Colton. 4, good. Okay. -1, no plus or minus, so we have to come in from both sides. Here's that -1 location. Trace the left, trace the right. Looks like they're meeting up, so our limit exists. What is that point where they're meeting, Anastasia? -1, good, we're on a roll. Okay. Part C, as we approach -3, no plus or minus, so we have to come in from both sides. Trace the left, trace the right. Are they meeting up? No, automatically. So what's our limit? Does not exist. All right. Next one. As we approach 2, just from the left. So here's that x value of 2. We're just going to trace the left-hand side. What's the height you're getting closer to? 1. Good. Is that what you had back there, girls? Yes. Good. Okay. Good. Let's try the next one. As we approach 2, just from the right-hand side. So find the graph on the right and trace it. What height are you getting closer to? Go, Stevie? 6, exactly. Again, we don't care if there's a point there or not. Okay, we're just concerned with what are we getting closer to. All right, last two on the bottom. As we approach 2, so if you were to trace the left and the right, would they meet up? No, and we can clearly see that here, right? The left-hand side approached 1, the right-hand side approached 6. Clearly those are not approaching the same thing, so that doesn't exist. What about if we were to trace forever to the left? -infinity? What are we getting closer to? Go ahead, Stevie. 2, good. And what about forever to the right? Go, Stevie. That would be positive infinity. Perfect. How'd you do? Not too bad? No? All right, go ahead and try another one. Page 19. All right, let's check out our first one. If you approach negative 3 from the left, what are you getting closer to? 0. Negative 3 from the left. We don't care if there's a hole there. We just care about what are we approaching. We're getting closer to 0. What if we approach negative 6? We got to check both sides. There's no plus or minus. What are you getting closer to? Go, Stevie? Negative 4. Anastasia, I'm coming to you. Next one. What if we approach negative 1 from the right? Anastasia, do you want that one? Say it again. Oh, sorry, that I did the wrong one. I did positive 1. If you approach negative 1 from the right, go ahead. 2, perfect. Negative 3 from the right. 0 again. 4 from the left. Thinker. What do you think, Joseph?
Does not exist.
Why?
Because it
It
never reaches 4.
never gets close enough to 4. Do you see how we have a hole there that just stops the graph? If we had the arrow, that would be negative infinity, because notice how we're getting closer and closer and closer to 4. But the graph stops at 3. So there's no way for us to physically approach 4 because we're stopping at 3. Do you see that? Okay. What about if we approach 4 from the right, though? That would be negative infinity. Good. Okay. What about if we approached 4 from both sides, left and right? What do we get for a limit? Does not exist, okay? Notice how if we approach from the left, that didn't even exist. And if we approach from the right, we get negative infinity, but that's not even a real number. Clearly, those don't even match. So the overall limit from both sides wouldn't exist. What if we approach negative 4 from the right? What are we getting closer to? Negative 3, I like it. And what if we approach negative 4 from the left? We get negative 6. Good. Sorry, you can't see those. How do we do? Pretty good? All right. So we finished that first section much quicker than I thought we would. So tomorrow we're going to do some homework problems together. Just make sure this sinks in. Okay?